Now we're going to take a look at the inverts. So what I've given you here is a screen capture from Town of Brookhaven's standards for catch basins. And this is a cross section for one. You can see that we have the curb inlet up here with the grate and frame. Maximum of 2 courses of bricks that could be used. We don't want to see more than that, otherwise that means you didn't set your basin at the right height. And this is what your standard 4x4 catch basins look like. But what's this thing, this knockout? Well, most of these basins are manufactured with a thin section of wall that we see here. And by putting a thin section of wall, you can basically take a sledgehammer, get to draw a little bit, and break that out. And then you can insert your pipe. Now, this is a higher catch basin where the pipe comes in at a higher elevation than we have here where it comes in towards the bottom. But let's just take a look at the difference. If we have a pipe coming in here, then it goes out that side. So it comes in one way, goes out the other, plus you probably have some water coming in from the top as well. What Brookhaven does is they make a recommendation to put a small opening at the bottom. This is all cast into the concrete structure. An opening at the bottom and fill that with gravel so that any water that sits here seeps out. But what most municipalities do is they pour what's called a sump. And I believe we spoke about this in one of the previous videos. What they do is they fill the bottom of this in with mortar. This way, no water can stand in the bottom and mosquitoes can't breed. So that would get done later on, and this would just remain as a solid bottom all the way through there. But what we're going to do is we're going to now figure out what's the invert. So we look at what this pipe actually looks like. The pipe has thickness to it. So we need to know what the invert is going in and what the invert is going out. And we typically use minus 0.10 feet from one side to the other. So wherever the water comes in, we want it going out at about 1/10 of a foot lower. Why 1/10? It's an easy number to remember, and it gives just enough pitch on the sump that water will travel across that. So can you go more than 1/10? Absolutely. Hey, listen, when it's your design, you pick whatever number you want. But for this class, just use 1/10. It'll make things simpler. So let me show you an example of what's going to happen here. We're going to have a pipe coming out on this side. So if we look at that pipe, here's the thickness of that pipe. We have an invert coming in, invert going out. If I look at the difference in elevation between those inverts, that would be 0.10 feet. So I want to have the inside being the high side and the outside being the low side. All right, so water will flow through there. For this catch basin to actually work, and this is why sumps are such a better idea than the way Brookhaven does it, this entire basin has to fill up with water before it ever can flow out of that pipe. So if this was my design, I absolutely would have put the pipes lower into the catch basin and then poured a sump. Okay, fill this whole thing with concrete. And this way no water can stay in there. And now the water just slides right out. Not only water, but leaves don't get trapped in there. And you know what the biggest thing we find inside these catch basins and also recharge basins? Cigarette butt filters. Because those of you who are still smoking, most of you are still throwing them out the window. Okay, stop doing that. You're littering horribly. But those filters are not biodegradable. They wind up washing into the drains and they wash into the recharge basins. If you ever get a chance to go into a recharge basin that's properly flowing, you will find tens of thousands of cigarette filters in the bottom of these things. It's pretty nasty. So stop smoking. Okay, let's look at the inverts now. On this one, whoops, sorry about that. I gave you an invert here of 150. We're going to go down and then down and down to figure out what the invert is at the recharge basin. What I've done is I've given you lengths of pipe for each of these, and I've also given you a slope of pipe. Now these slopes are not percent grade, so we're going to deal with them a little bit differently. So let's take a look at how we're going to do this. So we're going to set this up and label it. I think I'll do it below this. Just make it a little bit thicker so I can, my eyes are not as good as yours anymore. So from A to B, pipe A to B. We know that at A, the invert's 150. We want to find out what the invert is going at B. So we have our formula, change in elevation. Of course, you remember that. That is percent grade times the distance over 100. The only difference is we already have this. This is our slope in feet per foot, not as a decimal. So what we can do is if we take AB, that length of pipe is equal to, boy, my eyes are shot, 250 feet, not 900 feet. Holy cow. 250 feet. And the slope, 0.0090. So my change in elevation will be equal to 0.0090 feet per foot, so that cancels our units, times 250 feet. 250 times 0.0090, 2.25 feet. So at A, the invert was 150.00 feet. I'm going to subtract 2.25 feet from that on my calculator, not in my head, 147.75 feet. That's the invert at the end of that pipe. So this invert here will be 147.75 feet. So I have an invert here and an invert here as well. We like to match them. So I would also make this invert 147.75. This invert, we want to make a tenth lower, 147.65. This way the water flows through that way. Now I need this invert over here for BC. Okay, length of 175 and a slope of 0.11. So we have BC, length of 175, slope equal to 0.011. Let me just double check that. Yes. So my change in elevation will be equal to 175 feet times 0.011, 175 times 0.011, 1.925. Do I round it up or round it down? We always want to make sure that we are having a larger change in elevation to give a little bit more slope to that. So we'll make that 193. So where does that invert work now? This water is flowing in that direction. So this must be a higher elevation than I have here. So it would be 147.75 plus 1.93. 1.93, 147.75 plus 1.93, 149.68. This is 149.68 feet. So 147.75 plus 1.93 feet is equal to 149.68 feet. That's at C. Okay. So now we're going to look at BD, 1% and 275. BD. I'll set them up over here. BD. Slope is equal to 1%. Length is equal to 275. Okay. So, change in elevation. 1% over 100, because we have a percent now, we have to change it over, times 275. 1 divided by 100 times 275, 2.75 feet. So that's my change in elevation. That will then be used. We were at 147.65. 147.65 feet minus 2.75 feet brings me to 144.90 feet. So this is 144.90 feet. As I go through a catch basin, I want to drop by a tenth, 144.80 feet. And again, it's just a standard number that I work with. It's easy to remember, and this way it forces one pipe to be a little bit lower than the next, so water flows through. So now I have, excuse me, DE, 225 and 0075, DE. So DE, length is equal to 275, slope is 0.0075. $225, that's would help. I gotta get glasses. Okay. So, change in elevation. 0.0075 times 225. My change in elevation will be equal to 225 times 0.0075, 1.69. I'm going to take my 144.8, subtract 1.69 from that. 144.8 minus 1.69, and I'm going to get 143.11 feet. So that brings me here, excuse me, 143.11 feet. Right now I want you to pause the video and I want you to figure out on your own what the invert elevation is at the bottom of the recharge basin E. So pause it here and see what you come up with. All right, welcome back. So to get to the recharge basin, slope of 300.0009. EF, slope of 0.0009, length of 300 feet. So before we can actually get into the pipe sloping, we have to drop down on this side, 143.01. We still drop down a tenth in a manhole because we want that water to slide through. You don't want water standing in the bottom of these things because it will breed mosquitoes, and that's, you know, you can see the health problems we have with little viruses. Mosquitoes are horrible insects for transmitting disease and viruses. So now we can figure out that change in elevation, and hopefully you get what I get, or I get what you get. Change in elevation is equal to 300 feet times 0.0009 feet times 0.0009. Change in elevation is equal to 0.27 feet. Very slight movement. So what was our number? 143.01. So 143.01 minus 0.27. Our basin should end at 143.01. That's not right. 143.01 minus 0.27. That's 142.74 feet. That's where it's going to end. So that will be 142.74 feet. Okay, so you've just designed the pipes and you figured out the inverts on those pipes. Those inverts can also be used to give you slopes. If you know the change in elevation between two ends of a pipe, and you know the length of that pipe, rise over run gives you what the slope is. So we can use these same formulas in several different ways. One thing we always talk about or should think about in terms of designing these recharge basins is, should you be designing it from the low point back up to the high point, or from the high point down to the low point? And I hate to say it kind of depends. Generally, you start with the location of the recharge basin. You have to figure out where groundwater is, because the bottom of that recharge basin also needs to be 3 feet above groundwater. It acts like a leaching, think of it as a giant open-sided leaching pool. You're going to be 3 feet above groundwater with the bottom of that leaching pool, bottom of that recharge basin. So that gives you an end point where or you could look at that as a starting point of how deep into the ground you can go, and you can kind of work your way up from there. Other times it might be more advantageous to work with your catch basins being roughly 5 foot, about 5 feet below grade to the invert of that pipe, and then see where, as your roads work downhill, how it all flows. But that's the basic design behind that. So that takes care of our pipe flow calculations, and also takes care of our invert calculations. So I'm going to end the video with that.